Hello, thanks for stopping by. When last we left our PTR signal tracer yesterday, we were trying to figure out whether in fact the MPF 102 JFet actually was providing more gain. It sounded like it, and initial tests, seemed to show that it was, but I wanted to take and try to prove it conclusively. Now, if you take a look, here's the data sheet on the J310. You can see it's listed as a JFet VHF UHF amplifier. And like I said, it's supposed to be, an almost direct replacement for the MPF 102, which is why I went with it, because it was easier to take and locate, good ones anyway. Now, looking at the data sheet here for the MPF 102, you can see that's listed also as a VHF amplifier. And otherwise, the specifications are almost identical between the two. I mean, they're super close. So what I did is I took and made up a little circuit to approximate what we're using in the PTR. I put the same components in the 10 nanofarad capacitor, feeding the signal in through a 100K resistor to the gate with a 2.2 meg resistor to ground, and then the voltage coming in, the J310, I'd taken and found that it was optimized with a 13K drain resistor and a 4.3K source resistor. And the signal I fed in was a 100, 100. I'm okay. It was a 1K audio signal off my little signal generator. And it looked like this on the screen. I took and adjusted it to just about 10 millivolts on the input. And then measuring the output of the J310, it was just about 120 millivolts. So what I did then was I pulled the J310 out, put the MPF 102 in, and I went back to the 15K and the 3.3K from the original circuit for the MPF 102. And you can see here the difference. It's almost twice the signal coming out. So it wasn't just me hearing something different. The MPF 102 is definitely the better MOSFET. It's nice clear signal, and twice the amplitude of what the J310 was putting. So I think that's what we're going to be using in the PTR. Now, the other trouble we were having, which Doug noticed more than I did, is that at first was that the RF input signal was a lot less than the audio input signal. In terms of the same signal fed through the audio and through the RF, there was a drastic difference in the sound. So I took and went and recreated a bunch of different input signals from different signal tracers and compared them. Now, here again, the input that I was using on this was a 10 millivolt audio signal, and then I was measured the input coming out or coming into the J310. So on the other side of the 10 nanofarad capacitor. So this is what the JFet will be seeing. Now the original circuit for the PTR is this one here that we've been using. Input comes in through a 1 nanofarad capacitor, which is 1N34A to ground, 22K resistor to ground, and the signal's fed up through a 4K7 resistor to the 10 nanofarad input capacitor. And this is what the signal looked like. You can see that it's very distorted and, you know, not really super strong. And you're looking only, you know, at about 10% of what the input. The input was, I think I misspoke. The input was 100 millivolts, and we're only getting about 10 millivolts peak to peak coming into the JFet from that. So what I did then is I took and went back to the original circuit for the JFet preamp, and this is what he was using for the RF input. He had a 100 picofarad capacitor, 1N914 going to ground, 15K resistor, and then the other side of that with a 1 nanofarad shunted to ground. And this is what that signal looked like. Now, it's a lot cleaner looking signal, but you can see it's still, you know, roughly around 10 millivolts. It's still like only 10% of what the input is. Then I took and made up this circuit. This is the circuit used for the Heathkit IT5283 signal tracer. They're just using a 1N34A diode in line with a 1 nanofarad capacitor feeding right into the circuit. And this is what the output of that looks like. Now you can see it's a lot stronger, but if you look at the waves there, it seems like almost all of the 1N34A circuits are noisy like this. And I tried, you know, half of my 1N34As to make sure it wasn't just a bad diode that I had there or whatever. But you see that, you know, there's a lot of what I consider noise on the line. And we're getting like, you know, 13 to 15 millivolts peak to peak signal there. Next I took and built up, this is the input that Don uses with the ROR signal tracer. The signal comes in through 1N34A just like the other one, through 1 nanofarad capacitor, and he has a 220 picofarad capacitor going to ground. And this is the signal there. It's a little cleaner, you know, that 220 picofarad capacitor seemed to take some of the noise off the line, but it's still, you know, considerably down from the you know, 100 millivolt input signal. So what I did then was kind of make a combination. I took 1 nanofarad input capacitor, because I like to have a capacitor right on the probe where it's coming in before it touches anything else. And I shunted that to ground with the 220 picofarad capacitor. Then I used a 1N5711 Schottky diode. And this is the signal coming out of that, which you can see is a lot stronger. It's almost full screen there, and it's a lot cleaner signal. So I think that's going to be what we're going to take and want to use, you know, going forward with the PTR. I took and modified the circuit to take and use that. And this is a picture of the current quote-unquote 8-bit board, always subject to revision if I find something that works better. So I hope this made sense to everybody, and thanks for dropping by. Have a nice day.